Welcome to The Explainer. Today, we're diving into one of the most ridiculously complex manufacturing processes on the entire planet, making the computer chips that, let's be honest, run pretty much everything. It's this wild journey that literally starts with sand and ends with something that feels a lot like magic.
So let's just jump right in. A single modern computer chip, that little thing smaller than your fingernail, can be crammed with over 50 billion transistors. And what are transistors? Well, they're just these unbelievably tiny on-off switches that are the bedrock of, all digital logic and memory.
To really wrap your head around that number, you have to think about the scale. Okay, so a single human hair is about 100,000 nanometers wide. Some of the transistors we're making today are as small as 4 nanometers. That means you could line up more than 20,000 of them side by side across the width of just one hair. I mean, it's basically impossible to even picture. And that right there brings us to the biggest question of all. How in the world do you manufacture something with billions of parts that you can't even see with a regular microscope? You're definitely not building them one by one, right? So to even begin to get this, we first have to just accept the world we're operating in. We're talking about an impossible scale, a world where features are measured by how many atoms wide they are. The secret isn't about building these things piece by piece. It's about projecting all of them at once. The whole process is really about drawing circuits onto silicon. And the pen? The pen is light itself. This incredible tech is called photolithography. It literally means writing on stone with light. It's the absolute key technology that lets us mass produce these things on a microscopic level, creating billions and billions of transistors all at the same time. So how does it actually work? Well, first you take a perfect disk of silicon, it's called a wafer, and you coat it with a light-sensitive chemical. Then you beam light through a kind of stencil called a mask, which projects a super shrunken down pattern of the circuit onto that wafer. Where the light hits, the chemical changes. After that, the wafer gets a chemical bath that washes away all the exposed parts, and a final etching process carves that pattern right into the silicon. And get this, they do this hundreds of times, layer by layer. To make this feel a little less abstract, a lot of people compare it to screen printing a t-shirt, right? You've got a design, you've got a screen, and you transfer that whole pattern in one go. Or, here's another way to think about it that I really like. It's like painting a wall. You use masking tape to cover up the areas you don't want to get paint on. You slap on the paint, and when you peel the tape off, you're left with these perfectly crisp lines. Photolithography is basically doing that, but on a microscopic scale with chemicals and light instead of paint and tape. And this whole process of coating and etching, it's not just for one flat layer. This is where it gets really wild. By repeating these steps over and over again, engineers aren't just drawing a circuit, they're building an entire microscopic city. I'm serious, a modern chip is a true three-dimensional marvel. Picture it like a super dense city. The transistors are all the buildings on the ground floor. Then you've got layer after layer of copper wiring, sometimes over 100 kilometers of it on a single chip, acting like these intricate highways, overpasses, and tunnels that connect all those billions of buildings together. But as engineers tried to shrink those city blocks down even smaller, they slammed right into a fundamental law of physics. The wavelength of the light they were using was just too big. It was like trying to draw a microscopic line with a giant blurry crayon. The light itself was just too clumsy to create the sharp patterns they needed. The solution sounds like it was ripped straight out of a science fiction movie. To generate light with a wavelength that's short enough, you take a tiny, tiny droplet of molten tin, drop it in a vacuum, and you blast it with an unbelievably powerful laser. Not just once, but twice, in midair. Zapping that tin droplet creates an intense plasma that flashes with something called extreme ultraviolet, or EUV light. This is EUV lithography. It's the absolute bleeding edge technology that was pioneered by a Dutch company called ASML. And here's the crazy part. They're pretty much the only company on Earth that can make these machines, which gives them this massively important role in the entire global tech industry. Now, this incredible dance of lasers and tin and chemicals can only happen in one of the most extreme environments on the planet, the clean room. So a former quality control engineer shared this on Reddit. They said that everyone working in the production area, the fab, wears these head-to-toe cleanroom suits that they nicknamed bunny suits. The air inside these places is thousands of times cleaner than a surgical operating room. Why? Because a single speck of dust can totally ruin hundreds of chips.
And get this, the stakes in here are just unbelievably high. When things go wrong, there are no do-overs. If a wafer has even a tiny flaw, it's not recycled or fixed. Nope, it's put into a locked plasma oven and completely incinerated. In 10 minutes, it's just unrecoverable ash, and there's no way to stop it once it starts.
But even in this super sterile, high-stakes world, there's this really cool human touch. The same engineers shared that when universities would design chips, students would often use the empty space left on the wafer to etch tiny hidden works of art, like their university logo, their signatures, or even little cartoon characters. It's like microscopic graffiti. This whole process is an absolute marvel of human ingenuity. It's incredible. But as you can probably guess, creating this level of perfection at this scale, it comes with a pretty steep environmental cost.
These fabs, they run 24/7, 365 days a year, and they are just bottomless pits of resource consumption. We're talking colossal amounts of electricity to power everything, vast quantities of ultra-pure water for constant cleaning, and this complex cocktail of different solvents, acids, and gases.
In fact, just to put that into perspective, according to TED Ed, processing just one of those silicon wafers, which is about the size of a dinner plate, can generate almost 10 gallons of chemical wastewater by the time it's all said and done. So yeah, the overall environmental impact is a huge, huge challenge for the industry. We're talking massive energy and water use, potent greenhouse gas byproducts, and the use of those nasty forever chemicals. It's kind of the hidden environmental price tag that's attached to every single smartphone and laptop we own. And this isn't some far-off problem. The trade-offs are getting really, really stark. In some of the big chip-making hotspots around the world, the demand for water is so intense that governments are actually starting to ration water for local farmers just to keep the fabs running. And all this leaves us with a pretty critical question, doesn't it? We've built our entire modern world on these tiny silicon cities. They're absolute marvels. But the way we make them is pushing up against some really hard environmental limits. So as we keep moving forward, how do we innovate not just the chips themselves, but the way we actually build them to create a smarter future for both our technology and for the planet?